We're on 7-6 homework. Number 1. How is the symbol f parentheses x read? We read this f of x. Next up, we had number 4. If f of x equals 4 times 0.12 raised to the x, find each value. So when they say find f of 1, what that means is go ahead and plug in 1 for x in the function. So we are raising this to the first power. So it's 4 times 0.12 raised to the first, which you don't even need to put there. Anything raised at the first is just itself. So my final answer right there, 0.48. Part B, f of 3 is 4 times 0.12 raised to the third, plugging in 3 for the x spot. .006912. And then part C was a little bit goofy because in the calculator, this graphing calculator specifically doesn't like this number because it's so small and has so many decimal places. So let's try it. It's f of 5. You're plugging it in. So 4 times 0.12 raised to the 5th. When we plug in the graphing calculator, it brings up this e negative 5. That the negative 5 means that I have to move that decimal place 5 to the left. If I do try this, though, in a different calculator, a scientific, 4 times 0.12 raised to the 5th. This calculator, because it projects all the numbers across the screen, does have enough room here. And so you can see if the decimal was here between the 9 and the 9, and you move it 1, 2, 3, 4, 5 spots, like this said, this is what we're looking at. So the book rounded it off, but technically the answer is 0.00, count them out, 4 zeros, 99533. And the book rounded it, but I'm going to go with that exact answer right there. Okay, number 5. Let p be a function where p of n equals 100 times 2 raised to the n. We're going to find the value of p of n when n equals 7. So we're going to go ahead and plug in when n equals 7. So it's going to be 100 times 2 to the 7th power. And we get 12,800. We skipped 6, jumping to number 7. Looking at the table, all the answers are there. We don't have to do any work. It's the amount of money earned by a person who works X hours. So this is X, this is f of X. It's like X and Y. Y is synonymous with f of X. So we want to start realizing that here's X, here's Y. Y is the same as f of X. So it says, what's the value of f of 5? So what that's asking you is, what's the value of the function, or what's the Y value when X, because if you notice, when we write f of X, right, there's the X. So we write f of 5. So that's the X equals 5. So if f equals 5, f of x, if x equals 5, f of 5, we get 45. So the value of the function when x is 5 is 45. The y value when x is 5 is 45. Part B, f of 15, when I plug x in and it's 15, I'm going to get 135. And part C, now it's talking kind of backwards. We want to find x, so we're looking for this value. If f of x, the value of the function, if y equals 180. So here's my f of x column, here's 180. This is my y column, here's 180. What's the x value? It's 20. Number 8. H of n equals 0.5 times n. So for letter A, we're going to calculate h of 0. So again, we're plugging 0 in for n. This is like saying y equals, okay? So we're not plugging in and doing any math over here. This is just saying the function, h of n, equals 0.5n. This is the expression right here that it's equal to. And so we're plugging in 0.5 times 0. So that's 0. H of 1, we're plugging in 1.5 times 1. That's 0.5. And then h of 2 is 0.5 times 2, which is 1. Okay, part B. Calculate h of negative 1 plus h of negative 2. So you're going to calculate those separately, and then we're just going to add them together. So h of negative 1 is 0.5 times negative 1. It's negative 0.5. H of negative 2, 0.5 times negative 2 is negative 1. And now we're going to add those together. So negative 0.5 plus negative 1 equals negative 1.5. And then letter C, why do you think the letter H was chosen for this function? Okay, if you look at what's actually going on, okay, we're taking whatever n is, which is just a number, multiplying by 0.5. And when we do that, what we're actually doing is just taking half. When you multiply by 0.5, you're taking half. Okay, so what's happening to a number is you're taking half, so it's the function h of n. So h represents taking half. Okay, 9a. Computers purchased for $1,600. It's going to depreciate at a rate of 25% per year. And so we come up with this equation starting at 1,600. If we go down 25%, it's now worth 75% per year. We're going to evaluate W of 4. So this looks like the kind of equation we're used to. We just haven't had this. It would say Y equals or C equals. So now it's W of T. And so we're going to go ahead and plug in 4. So basically, W of 4 equals 1,600 times 0.75 raised to the 4th. You're just plugging in and you're solving here. So 1,600 times 0.75 raised to the 4th. It's 506.25. And it says explain what that means. So the computer is worth $506.25 after 4 years. We plugged in 4 for time, 4 years. We found the value now is $506.25. So just explaining that we understand what we're doing with the numbers. We're not just plugging into a calculator, getting a number that we don't really know what it means. Okay, we're doing 10A, B, and C. So we have L of x equals 12x minus 18. We're going to calculate L of 5, which just means we're plugging in 5. 12 times 5 minus 18. So that is going to be 60 minus 18. So L of 5 equals 42. Part B, we're doing L of 3. 12 times 3 minus 18. That's 36 minus 18. So L of 3 equals 18. And C, we're going to take L of 5 minus L of 3, and we're going to divide that by 5 minus 3. So if I go ahead and simplify over here, I'm going to get 2 on the bottom. And we already know L of 5 is 42, and we know L of 3 is 18. So we just got to do 42 minus 18 on top, and that's 24. And the last thing you want to do is just divide that. So 24 divided by 2 is 12. Okay, so number 11, we're looking at this graph. It's talking about oven temperature. So we have time passing represented by T. The initial temperature, the starting temperature was 80 degrees. Okay, the temperature of the oven is set to 325, and so it slowly heats up. Okay. The actual temperature was measured here, so you can see it passes 325, hits 350. It's kind of like the oven shuts off, and then it drops below 325. The oven kicks back on, gets above 325, kicks back off. So the oven's keeping it as close to 325 as it can. All right, and we're going to express this function where t equals f of t. So the temperature equals function of time. So we're going to estimate f of 25. Okay, so look at little t. That's what 25 is going in for. So you find little t. You go to 25. We're estimating where the function's at. And it looks like it's right in between 300 and 350. So that would be about 325. What is the meaning of f of 25? So give some meaning to the numbers. So after 25 minutes, the temperature is 325 degrees. Letter C, estimate the solution to the equation f of t equals 200. So f of t, the function equals 200. Okay, so we're equaling 200. We're looking for t. What is t? So when I find where it's 200, it's not 5, it's a little bit past it. So I'm going to say that t is approximately 6. D, explain this right here. So that means after 6 minutes, the temperature is 200 degrees. Okay, number 12. Could the table of values represent a function? That's what they're asking you. So to be a function, every x value can only have one y value. So for number 12, if I look across all my x values, they all just show up once, and each one of them just has one matching y value. So my answer here is yes. They say why or why not. So I'm just going to explain it. Every x value has only one matching y value. (13) though, if you look across it, I see 1 show up in 2 different spots. I see 0 show up in 2 different spots. And when they show up twice, they have different matching y values. So if I asked you when x equals 1, what's y, you'd have to give me 2 answers, which means this is not a function, and explain why or why not. And I'm just going to give a specific example. When x equals 1, the y value is both -2 and 0, both. Okay, and that can't happen in a function. 14, we've got this equation. Part A, is 2, 3 a solution? So we have 2, 3. What that means is x equals 2, y equals 3. We're going to plug that in and see, is that a solution? So I'm plugging 2 in for x, so that's 2 squared. I'm plugging 3 in for y. And I specifically put it in parentheses just so I remember to take y and square it before I multiply. You can't do 3 times 3 and then an exponent. You got to follow PEMDAS, so you're squaring first. So I'm going to show this step by step. 2 squared is 4. It's 3 times 3 squared. 3 squared is 9. Okay, so that first multiplication before you add is 27. And so I get 31 equals 31. So to answer the question, is this a solution? Yes. Part B. We've got 2, -3. So x equals 2, y equals -3. We're going to plug it right into the equation. So 2 goes in for x again. This time it's -3 going in for y. So you can see there's not much difference here. This is going to be 4. Negative 3 squared, that's negative 3 times negative 3. Two negatives make a positive when they're multiplied. So this is going to become positive 9. And so now this looks just like the one above it. And so is this a solution? Yes. So I can answer part C. Is this the equation of a function? I would say no. And they want you to explain why. Okay, I have 2 as my x value with 2 different matching y values. So I'm going to say when x equals 2, the y value is both 3 and negative 3. Okay, so we are going to rewrite this in a couple different forms. Just working on your algebra skills, manipulating an equation. So first, standard form. Which, if you remember, is ax plus by equals c. So we need x and y on the same side. All right, so I need to bring this x on this side. And when I do that, I'm going to end up with, if I do that, I'm going to end up with a negative x on this side. And if you remember, we always want this a to be positive, the coefficient there. So if I move 6x over here, I'd be minusing 6x, and I'd get negative 10x, and I have to do more work later. So I'm actually going to go ahead and put this on the other side. So I'm going to go ahead and add 4x to both sides. So I'm still going to have 8y. I'm still going to have plus 1. Still going to have 25. But now I'm going to have a positive 10x over here. X and y need to be on the same side, so I'm going to minus 8y to get it over here. And while I'm doing that, I might as well move this number. This 25 is going to have to go on the other side, so let me minus 25. And you can do multiple things at once. Just make sure, here's your dividing line, here's your equation. You move things. If you do it on one side, you do it on the other. Okay, so these are going to cancel. 1 minus 25 is going to be negative 24. And then over here, I'm going to have 10x minus 8y. Okay, this is in standard form. Now you'll notice that the equation given in the answer key doesn't look exactly like this. What they always do is they simplify these numbers as much as you can. So you can divide this entire equation, if you look at it, by 2. So they're always going to do that. And so I'm going to do that, and I'm going to shift this to the left side like we're used to seeing. So 10 divided by 2 is 5x. Here, this is going to be a minus 4y. And that's going to equal negative 12. So there's standard form, fully simplified, reduced, all that jazz. Okay, next it wants me to put it into slope-intercept form. Which is y equals mx plus b. So I need the y by itself. So I'm going to go straight from the equation that I've already got, because that's pretty simple. I just need to get y by itself. So I'm going to minus 5x to this side. So I have negative 4y, negative 5x, minus 12. All I got to do is divide by negative 4. Y equals, 2 negatives make a positive. I'll just leave it as 5/4 x. 2 negatives make a positive 3. And there you have it, slope-intercept form.